All right. Thanks for watching, especially during this home learning time. Awesome. So we did a few of them together last time, and so I just thought I'd do one more video to really help you understand when you have two triangles. And we are on a trial basis right now. We got this home learning. Stay home, don't spread it. So number one, we went through together. And we learned that because of the angle and sides they gave us, we could actually come up with two different triangles. So two different triangles. And so we had two different triangles. One that was an obtuse triangle with a rather large angle. And so that really large angle was 110.6 degrees. And then we also had an acute triangle with 69.4 and 54.6 degrees. And so that was our acute triangle, and then our obtuse triangle had a big angle and little angle. So now we're just going to take a look at number 3 and even 4 to make sure that we kind of get how we have maybe 1, 2, or 0 triangles. And so let's just take a look at number 3 together. What do you think it's going to be? Do you have a hypothesis? What do you hypothesize? Right? So hypothesize probably, if you looked at the last video, probably 1, because I showed the answer key in the last video. So 69 degrees, we'll call this angle C, because that's what they first give us. And then across from angle C, that's definitely not straight. So then, there you go. So here we go. Nice. Still not straight. There we go. Straight line, U-bolt. There we go. Straight line, we got this. Straight line, we got this. Okay, so then they also give us that one right there. And so that is little c. And little c is 18 inches. Awesome. Then they give us little b. Whoa, that is small compared to c, 18 inches. So little b is only 4 inches. That might be an indicator for something. Indicator for something. Okay. So first, we just go ahead and try to find this little angle down here. And that's the angle across from the angle they gave us. Cool. And so that's going to be across from little b is big B. So we'll go ahead and do that. We'll do sine of angle B over little b. That's so small compared to the 18. 4 is so small compared to the 18 inches. So sine B over little 4 over 4. Is equal to, they give us sine 69 degrees, good, over 18 inches. Because remember, it's the angle over the side length, right? Angle over the side length. Okay, so then we're just going to go to multiply 4 to the other side because we're solving for angle B. Solving for angle B, there we go. And then we want to undo sine to the other side, so we actually solve for angle B. And so if we do inverse sine to one side, we also have to do inverse sine to the other side. So we have the inverse sine of 4 times 69 degrees. Awesome. And then divided by 18. So let's plug that into our calculator. And you go ahead and pause me and you do it right now. You plug it in. See if you get it right. What did you get for angle B? So we'll plug that into the calculator. So we go second sine, inverse sine of 4 sine 69 degrees. Don't forget to close parenthesis. Please close parenthesis. Divided by 18. Close parenthesis. Also make sure before you push enter that your mode is good in degrees. If it's in radians, make sure you put in degrees. So then we'll go and push enter. And we get 11.97, which rounds up to 12. If we round to the nearest tenth. So we have angle B is equal to 12 degrees, which makes sense because we have a small side and a small angle. Awesome. So then we have 12 degrees here. Cool. So then if we want to find angle A, we're guessing that that angle A is going to be huge, right? So we're going to go 180 degrees minus 69 minus 12 to find what angle A is. Awesome. So we go 180 minus 69 minus 12. So we get 99 degrees, which is bigger than 90. Bigger than 90 degrees. So this will, in fact, be an obtuse angle, even though it doesn't look like it, not drawn to scale. So 99 degrees does indicate that this is an obtuse, right? Obtuse angle. So it does indicate it's obtuse. Make sure we're still recording. Good, we are. Okay, so that's an obtuse angle. Cool. So then we think, okay, well, can we have another angle? I don't know. That's already obtuse. What do you guys think? So we're going to take this like we showed you before, and we're going to go ahead and, well, we could just clone it there. Boom. Okay, awesome. So now we're going to go ahead and take that and, whoa, rotate it. Wow. Wow. There we go. And now we're going to take that and we're going to go ahead and rotate it a little bit and see what kind of angle that's going to give us. Now because, whoa, because 12 is kind of small, that might definitely affect us having another angle, right? Can you think of it already or no? Okay, so then that's 69 degrees. So that means that this other side will also be 12 degrees, and then we'll have 180, right? Minus 12 degrees. And so, because that's full thing there, so we're just looking for this obtuse angle that we're trying to find. Okay, so then we do 180 minus 12. Whoa, it gives us 168. That's crazy. Guess why that's crazy? Can you guess why that's crazy? No, not yet? You don't see it yet? Don't see it yet. So if this angle right here is 168 degrees, what does that tell us? Well, if that angle is 168 degrees, then this angle can't be what? Well, they gave us it at 69 degrees, and the problem is now 168 plus 69 degrees is well over 180. So we can go ahead and see what that's over 180, which is bigger than a triangle. Make sense? Could probably make a postulate at this point. So it's bigger than a 180 degree triangle. And so that means that this obtuse triangle does not exist. So it's only going to be this one. So this is only going to be one triangle. And so that's going to be our answer for number 3. And we can indeed just go ahead and find that other side length just to finish it off, since eventually you're going to be solving all the sides and all the angles, but just one triangle for number 3. And so what would you do to find that angle? We call this little a, I mean that side length, little a. And so you do a over what we found, which is sine 99, good. And then equals the opposite, so 18 over sine 69. And then we just multiply sine 99 over the other side, just to make sure it exists, which it will. So 18 times sine 99, so we're going to multiply sine to the other side, divided by sine 69, there we go. And so that gives us 19.04. And so which is bigger than the other side, which is what we wanted, because bigger angle, bigger side. So 19.04, nice, nice, there we go. And so there is all our sides, all our angles, and number 3 is definitely one triangle. What'd you get for number 4? Pause me and try number 4. Pause me. Please, so help me, pause me. Right? Pause me. So they give us, did you pause me? I don't think you did. You better pause me. So give it a try on your own, number 4. Okay, I'll pause then. For the length of time it takes for you to do it. Come on, try number 4 on your own. You got this. Okay, so then across from big A, angle 136 degrees is little a, equals 32 miles. Good. And then we have, you can label either side as C. So I'm going to go and label this as angle C. And then across from big C is little c, which is our side length. So then we can ask ourselves, first of all, we have a big angle and a big side. Does that match? It does match because 32 is indeed greater than 29. So that's pretty golden. That's good. That's a good thing because last time, if you remember, when we did number 6, it could not exist because 21 wasn't bigger than 29. 21 wasn't the largest side with the largest angle. But that definitely works. Good, good. So there we go. So then, since we have a nice obtuse triangle there, can we find the other triangles there or not? Well, using law of sines, we can. So first of all, we want to go ahead and find sine, right, of angle C. There we go. And so sine of angle C over little c, which is 29, equals sine of 136. Good, good. Make sure this triangle exists. And so we'll go ahead and multiply, remember, 29 to the other side. And then we'll inverse sine both sides to solve for angle C. So we'll do the inverse sine of that whole shaboozy. There we go. So then we go inverse sine of 29. Good. Inverse sine 29. Sine 136. There we go. Divided by close parenthesis. Divided by 32 close parenthesis. Gives us 39 degrees. Nice. So then we know this is 39 degrees. Good. And then if we do 180 minus those two to make sure this triangle exists. So minus 136 minus 39. So that gives us a really small 5 degrees. Cool. So then little small 5 degrees there. And then can we find its opposite side, which we will call, if this is A and this is C, this must be angle B that we just found. Which, why did I call it C? Oh, no. We already had C, right? C, no, we didn't. We just found it. It was 39 degrees. Yep, so then good. So now this angle B is 5 degrees, which we just found. So let's go ahead and find little b just to make sure this triangle all exists. So then you would do, let's see. No, B. Oh, yeah, finding B. So B over sine 5 degrees, which is angle B, is equal to, we can use A again since that's what they gave us. Always good to stick with what they give you just to make sure. Over 32. And then we're just going to go to multiply again, sine 5 over to the other side. Whoa, Newbold, whoa, what you doing? Sorry. Just getting carried away, What do you mean, Newbold? Side over sine of an angle equals side, which in this case, it was 32. Did you catch me? Good. Over sine 136. And now we're going to multiply sine 5 over to the other side. That looks better. Never usually have two signs together like that. So cool. So now we'll do 32 times sine 5, close parenthesis, divided by sine 136, close parenthesis. So we get 4. 4 miles is what we got here. And that does make sense because the smallest angle, we have the smallest side. So now the other question is, given this information, can we find another triangle there? Well, the problem is we already started with the obtuse angle, so that's kind of it, right? But let's try to rotate like we did before to see if it rotates or not. Remember? So they gave us 136 degrees, and then they gave us this really nice long side length there. In fact, it's even wider than that. As you can see, it's really wide because it's an obtuse angle. And so the trickiest thing is when you try to swing that leg around. Let's try it. Nice. So when you try to swing that leg around, can you make another triangle? Can you make an isosceles? Can you make something with that? And so when you try to swing that around, it's gonna, or I can't make another. That's because it's an obtuse angle that we already started with. So we can't swing it around and make another triangle there because it's, you see what's going on there? And so, because it's already obtuse. Where over here, we could swing this leg, as you could see. We could swing this leg around and kind of make it another triangle right there, which is the obtuse angle. Cool. And there's a bunch of rules and things that you can label, greater than 90 degrees, less than 90 degrees, 180, blah, 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 blah. But I just really look at this logically with the drawings, which is nice. All right, so appreciate you watching this video, mate. And so thanks for watching. Go ahead and try the other ones as well. Ooh, 8 is obtuse angle, probably just one triangle there. Make sure you find all the sides and all the angles for 7, 8 onwards, right? Solve each triangle set, solve each triangle there. Trying to circle it. There we go. Okay, so solve each triangle and each angle for this assignment. And thanks for watching. Keep on going. And thanks for watching. Keep on going. So don't forget to describe the end behavior as x goes to the left, negative infinity, right goes to negative infinity, as x goes to the right, positive infinity, y goes to negative infinity, because that depends on the sign, which in this case is negative, and it depends on the power, which is also the degree or the highest power. And remember, when it's even, it both goes up, or in this case, because it's negative, they both go down, right? Both go down. Awesome. And then if it's an odd power, remember odd? Remember this from before with polynomials? If it's odd, it's either going to go this way if the sign in front is positive, it's going to finish off positive, or if it's negative, for example, I don't know, negative x to the 5th power, for example, then it'll start off, but it'll finish negative. So don't forget that with our end behavior. Cool. And use the whole thing as x goes left, negative infinity, y goes to blank. As x goes to the right, positive infinity, y goes to blank. Don't forget that. It's kind of your format that you're going to write for every single one of those problems. Cool. So thanks for learning the ambiguous case, side angle with me. I'm your host, Mr. Newbold. Thanks for watching. Stay tuned for our next video. Thanks for watching 5.4 Law of Signs. Thanks for watching.